And also there are some thoughts on how to design fractional order PID controllers. In fractional order PID controllers, there are 5 parameters to choose: Kp, Ki, Kd, and apart from that, there are lambda and mu to choose. However, lambdas and mu's cannot easily be defined, so we usually have to make a match grid with increment of 0.01 for the incremental lambdas and mu's. However, in this case, if we use this kind of increment, then the total number of optimization process used should be 10,000, a large number. May take quite a long time. So I'm thinking of finding the optimum fractional order controller by introducing a decision variable like this. And here we say that, and we assume that these true values are integers. We multiply lambda and mu by 100. We say that this should be integers, and this one is equivalent to the requirement here. So we can now transform the original problem into mixed integer programming problems. In this case, x4 and x5 are integers, and we can perform multiplication. We can do some solution to this kind of problems and see whether we can find the results. And also, I think I published a paper at ACC conference a few years ago, at ACC 06. I did a case study on servo mechanisms. If you change the value way, you can control the angle of theta I, which is the load. So for this kind of system, and there are certain requirements for this system. For instance, there is actuator saturation here. The voltage to the motor could not exceed 220 volts. And there is also a quite tricky one requirement. The torque here should not be too large. If the torque here is too large, then the shaft may be broken. So this one is quite tricky in control considerations. How can we design controllers for it? So for the optimum ITAE criterion, I did design a few controllers. However, I think there might be errors in the result. I do the search again using genetic algorithm and found that the control result is much better than this one, even the integer order result, because I think this one is obtained as a local minimum, not global one. So the conclusion here may not be quite accurate. And there are some good behaviors in the results, in the fractional order results. If there are nonlinearities in the system, for instance, if there is frictions or dead zone nonlinearity in the Planck model, then you may see that the difference between the integer order PID controller, which is the best optimized integer order PID controller, and the fractional PID controller. You see that the blue line is obtained by fractional order PID controller. However, the green one, which oscillating one, comes from the integer order PID controller. Since there is a problem in the integer order PID controller, I said it is not a global minimum. I didn't try now whether the result is still the same. I'm not quite sure the result, but this was the result I obtained earlier. And it seems that the fractional order PID controller may be insensitive to the parameter nonlinearities in the system. I need to try this one again. Just found the problem, actually, even after I came here. And also, if there are parameter change in the plant model, for instance, if there is change in k theta in the plant model, the fractional order PID controller is also insensitive to that one. And this might be the conclusion of a question I want to pose. Is there exist a plant where fractional order PID controller is better than the integer order PID controller? Apart from this result, actually when I do pure search using ITAE criteria, I haven't found any good behavior. I haven't found any plant model which is more suitable for fractional order plant model. What I tried here is something like this. The FOPT plant, which is usually used for process control for different combinations, I didn't find a PID controller. And for servo mechanisms, if we only consider the step response, if we do not consider anything about the robustness, then I still say that if we find a global minimum controller, it is still better, or at least not as bad as the fractional order PID controller. Also, I tried a fractional order plant like this. I think that the integer order PID controller is much better. And there is also a very strange thing. If I do pure search, actually I cannot find the integer order controller. Since the integer order controller gives better performance, but I cannot find actually that point. That is quite strange. I have to do the search for integer orders and for fractional orders and compare them both. That is quite strange. I do not know why. So this is the presentation I need to give today. And there are certain remarks. First, I introduced a mini toolbox for fractional order transfer functions. I think you can use it later for your own research. It is quite easy to use. I think it is as easy as a control system toolbox. I did define the blocks, define the object in a similar way, and define the combinations, the analysis in a similar way. And also, I explained something about the filter approximation to the system. And then I presented something about regarding the optimum design of fractional order controllers and also integer order controllers. All the program you can download for your own research. Any questions? So we'll discuss your work today. Thanks. I think